All right, we are going to do a recap of learning of what you should have been exposed to in the videos that were assigned to you yesterday. Let's get started. So remember, another way to express arc sine would be inverse sine, and that's what you're going to see when you look at your calculator. So let's go ahead and let's come up here and let's turn this into degrees if it's not already there. So if everybody can do the exact same thing, you absolutely need to have a calculator in front of you to do any of the work today. Go up to mode and make sure that you are in degrees like I am. Okay, so what are we doing here? We have arc sine, and by the way, the directions are going to say to use the graphing calculator to evaluate the inverse trig expression, and then to express your answer in terms of degrees. Again, evaluate this statement, and this is an inverse, so inverse trig function. In this case, it's the sine function, and we're going to express in terms of degrees. So literally, you're looking up here and you're like, I see no arc sine, but equivalent to that is what we see in blue here. This sine to the -1 power is going to be the inverse sine or arc sine. So hit second sine, and we're going to type in exactly what we see, -0.1736. And so we can see that this rounds to approximately -10 degrees. Let's do the next one. Again, arc cosine is equivalent to the inverse cosine. So I'm going to do second cosine and then -0.5735, and this is approximately 125 degrees. I'm going to press pause. The directions for the second learning objective is going to say we can go up and use our answers from up above, or we can reproduce them down here. And we are going to find two values for each angle that can be found between 0 and 360 that satisfy this given equation. So if I look up here, I already know that the sine of this angle, oops, sorry, I meant to put equals here. There should have been an equal sign here and an equal sign here. Sorry for the confusion. We can see that, right? And so there should have not been an equal sign here, by the way. Like, cross that out. All right, so how can we do this? Well, we already can see up above that if I take the inverse of the sine of this value, I'm going to get -10. If I take the inverse cosine of this value, I'm going to get 125. But let's pretend for a second we didn't have that. How can we do this again? Again, I'm going to make sure I'm in degrees. Yes, I am. And then just like this, I always showed a student in a previous hour, I'm going to come up here. If I gave you this mathematical equation, really simple, and I said to solve, everyone would say, how do we isolate the x? You subtract. But here's the reasoning. The reason we subtract is what operation is opposite of adding 3? It is subtracting. That's the reason why. So if I said to you 3x equals 9, you would say we're going to divide, because opposite of multiplying is dividing. So that's when we come down here. In order to isolate not the x, but this variable, which represents the angle, what we're going to do is we're going to do the inverse of this. So we're going to write down what's equivalent to the inverse, arc sine. And over here is going to be arc cosine. It's the inverse of that. So like opposite of adding is subtracting, opposite of multiplying is dividing. When I want to isolate this angle, I'm going to take the arc sine of both the left and the right-hand side, knowing that we need to keep the equations balanced. Okay, so what's left on the left-hand side? Well, these are going to be simplified, or you can think in your mind is canceled out. And now I'm going to take my calculator. I know arc sine is going to be second sine. Okay, I've got that down. And then I'm typing this in, -0.1736. I'm going to press enter, and I'm going to write down -10 degrees. We're going to come back to that answer and make sure that it satisfies the directions in a little bit. So right now I'm at -10 degrees. Let's do the next one. So here, these are going to be eliminated, and now I'm going to do arc cosine of -0.5735. Okay, 125. So this is not my final answer, but I just want those to stand out. The directions said we're going to use these answers to find two values for the angle that have to be between 0 and 360. There's no negatives. You see that? 0 to 360. So one revolution around, and there's going to be two values that satisfy this given equation. Okay, let's do this. You ready? Here's the very first thing. How do I get to a negative 10? A negative 10, well, a negative says instead of going up, we're going to drop down. So we're going to drop down 10 degrees. I dropped down 10. You're doing the exact same thing in your notes. So from 360, I'm dropping down 10. I believe one answer is 350. But they said we have to have two answers. Where else do I find sign values that are negative? And you may be thinking, like, how did I know it was negative? The sign was negative. Does everybody see that? The sign was negative. What other quadrant, 1, 2, or 3, gives me negative sign values? 3. So I'm going to go to quadrant 3, and always from the x-axis, I will rotate up or rotate down. So to be in quadrant 3, I have to rotate down 10 degrees. Well, I know from here all the way around is 180, and 180 plus 10 is 190. So I believe that 190 and 350 are correct. And you may be thinking, like, Ms. Bradley, I don't know if I can do this on my own, and how can I check to see if I did it right? Please grab your calculator. I'm going to go back to this original statement, and we were asked to find two values that make this statement true, with the values being between 0 to 360 degrees. So along with me, please do this. Please take the sine of 190. And now it may be, because I rounded, it may be slightly different, but we can see it's pretty much the same. And now let's take the sine of 350. And again, we can see it's the same thing. Thumbs up or thumbs down? Let's go on to the next one. All right, our next one is a little bit nicer because I already have an angle that's between 0 to 360. And you're like, well, didn't we have an angle before? We did, but notice that it was a drop down of 10. It was a negative value, and I only want positives between 0 to 360. So let's approximate where 125 is. Okay, it's positive. I'm going to go up. So there's 90. And now past 90, I need to go another 35. So somewhere like right about here. That's my approximation. Let's figure out what this angle is, because I need to know that. Just like I had to know this angle back to the x-axis, I have to know this degrees to drop down, in this case, to the x-axis. So I've already gone 125. If I take 180 and I subtract 125, this is going to be a 55 degrees drop down to the x-axis. Now, why is that important? Miguel, can you tell me which quadrant, 1, 3, or 4, also has a cosine value that is negative? 3, you're right. So down here, I'm going to draw something similar. And now I'm always going to go from the x-axis. So to get down to this, I have to drop down 55. So I already know one of my answers, I believe, is 125. It fell in that range. But how do I come up with this angle? Well, I have to go half of a cycle, which is 180, plus an additional 55. Half of a cycle plus an additional 55. Half of a cycle plus an additional 55 gives us 235. Gives us 235. Again, you may be thinking, I don't know if I did this right. Let's go back to this original statement that we want to satisfy. Our goal is to find two angles between 0 degrees and 360 degrees that make this statement true. Let's try. This is cosine. So cosine of 125. Okay, good. And then cosine of 235. Great. So I've asked you to come up and grab in the front to grab a paper, and on the back side of that paper we're going to use the unit circle. So once you get done writing down both part A and part B of example 3, that's our third learning objective, we're going to use this unit circle on the back in order to be able to complete these two examples. So using the unit circle, we're going to evaluate each inverse trig function, and we're going to express our answer in terms of radians. Let's get started. So whenever I'm looking for an arc sine, I'm finding one answer that lands in quadrant 1 or quadrant 2. So I'm just for myself, and maybe you want to do this initially, I'm going to do this. Next, I'm going to turn to the unit circle, and I'm going to identify all of the points in the unit circle that have a sign. As a quick reminder, it's cosine, followed by sign. So let's find all of the places in the unit circle in which the sign is a negative square root of 3 over 2. You ready? Let's do that. So where do I find a negative square root of 3 over 2? Okay, signs, I'm looking. Well, signs are only negative down here. So there's one. Does everybody see this down here? So down here, David, can you come grab a paper and start taking notes? Down here at 4 pi over 3 is one option. And then right here at 5 pi over 3, 5 pi over 3 is the next option, okay? So these two options, I'm going to come back to my unit circle, and I'm just going to dot those in. This was 4 pi over 3, and this is 5 pi over 3. In order to correctly answer this, the point we choose must be in the shaded region, which means my only answer is 5 pi over 3. Okay. Now, is there a way to check this? Let's go ahead and let's check. So I'm going to do arc sine. Here we go. Arc sine of negative square root of 3. And then I'm going to divide it by 2. And this is what I have. Now, hold on here. Where does negative 60 occur? Negative 60 occurs right down here. And that is equivalent to the position of 5 pi over 3. Now, why didn't I put 300 degrees or a negative 60? Because they wanted to give us in terms of radians. That's why. Let's do the next one. Tangent of 1. Now, it says a positive 1. So the first thing I need to recall is all-star trig class. All-star trig class tells me that in quadrant 1 and in quadrant 3, the tangents will be positive. But I look up above, and I can only choose a position on the unit circle that's in quadrant 1 or 4. Now, how could I find out which of these has a tangent of 1? Remember, tangent is sine divided by cosine. In order to get a 1, they have to be the exact same value, which means I'm looking at either pi over 4 or 5 pi over 4. And which one does it have to be? It has to be pi over 4. It's in the shaded region. Again, once again, if I can show you this to you, if I do arc tangent of positive 1, I get 45 degrees, which is equivalent to pi over 4. Okay, directions for this fourth learning objective are a little bit different. We're going to use the unit circle again to find two values, and the values are going to land between 0 and 2 pi. So I don't want you to express your answer in terms of degrees. I want it in terms of radians. Notice that I'm not provided the inverse or the arc. I'm provided simply the statement that the sine of an angle equals square root of 3 over 2. So let's go back here and let's find out where is the sine equivalent to negative 3 pi over 2. Right here at 4 pi over 3 and right here at 5 pi over 3. 4 pi over 3 and 5 pi over 3. I believe these are the two answers. Now, could I check that using this? Let's go ahead. Let's see. If I come up here and I'm working within radians, so let me just change this over here. And if I do the sine of 4 pi divided by 3, this is what I get for an answer. And now let's see if that's equivalent here. Negative, I want to use that. I got to remember really quick, how do I get to the fraction? There's my fraction. Oh, I didn't want that. Give me a second. Does anybody remember really quickly how to incorporate the fraction? Is it here? No? I'm forgetting really quickly at this point how to make a fraction.
It's alpha and then like the one next to it.
Oh, thank you so much. Thank you. Square root of 3 divided by 2, and we can see they're equivalent. So that satisfied the first one. Let's do one more just to check. I'm going to do the sine. Notice I put it into radians first of 5 pi divided by 3. I get an answer, and now let's just make sure this works. We can see that is equivalent to negative square root of 3 over 2. They both work. Okay, you ready? Let's do this one. I'm going to give you right now 10 seconds to write down which positions on the unit circle from 0 to 2 pi satisfy this equation. Positive 1 is the key. Positive 1. In the previous learning objective, we already identified these two positions at pi over 4 and 5 pi over 4. So pi over 4, I believe, is one answer, and also 5 pi over 4. And again, I just want to show you one more time how we could do this. We could say the tangent of pi divided by 4, and we can see it equals 1, and we could do the tangent of 5 pi divided by 4. It also equals 1 because that's exactly what we desired.